Hello friend, welcome. So we'll introduce the third way to write function factorial and GCD, greatest common divisor. We already introduced two ways to do that. The first one is conditional expression. The second one is guarded equation. The third one today is pattern matching. Okay, so we'll review our first two of them. Okay, let's get started. So GHCI, and let's clean up those screen using Control L. Okay, so the first way is, let's do it quickly, right? F for factorial, Fn equals if n is 0, then we return 1, right? Else, there's no equal sign here. Else, we'll return n times factorial of n minus 1, right? So let's try it. Yeah, it works. And for GCD, okay, Mn equals if n is 0, we know we just return m, otherwise else we return g of this guy and mod m and like that, right? So g, let's try it. So 3 and 3, yeah, g 4 and 6 is 2, right? Okay, this is the first way. We called it conditional expression, right? Conditional expression. Okay, the second way is guarded equation. Okay, so how can we do that? Guarded equation. Oh, this is the comment. Let's see. Guarded equation. Yeah, it does nothing. Okay. And now we need multiple lines, so we'll do let. We have to use let to trigger the multiple line, but if it's not inside the GHCI, we don't need the let. If it's in like a text file, like a script, Haskell script, we don't need the let. Okay, so now we need that to trigger the multiple line editing. So let, for example, this one, factorial of n such that if n is 0, now we need an equal sign. Equal is equal to 1. Okay, now yeah, don't be confused with like this one. Okay, this is not this bar. This is our label to show it's not finished, right? It's still inside the function definition. Okay, so now this bar is such that is part of the guarded equation. So otherwise equals to, right, n times f of n minus 1. This is guarded. Okay, enter. So same thing, f, it works, right? 6 will be 720. Yeah, let's see if we can remove the equal sign, right? I think this is like a separator. So without that, it will be, it will be weird. Let's see, like that. It doesn't work. Yeah, it doesn't work. So okay. Oh, do we still have the F here? Oh yeah. Okay, the got it. Let's keep going. To review our guarded equation of GCD. So let G of M n, right, such that if n is 0 equals M. Now line up here such that otherwise is G of n and mod M n, like that, right? Oh, what's wrong? Oh, equal sign. Haha, I missed the equal sign here. Otherwise equal. Now good, right? G of 6 and 7. Okay, yeah, the greatest common divisor is 1. Oh yeah. Now finally we can talk about pattern matching, right? Our pattern matching implementation of our factorial and GCD. So pattern matching is like that. Let Fn oh, so yeah, so pattern match is like it's try to match from the top. Okay, let F 0 equals 1, right? Factorial of 0 is 1. Now F n equals n times f of n minus 1, like that. So there's multiple lines here. So when we call a function, right, like that, it will start to match from the top one to the bottom one. So whatever, right, whatever is matched up, then it will use that one. For example, if we call f of 0, then this pattern, right, matches the function call here. So it will return 1. Okay, so if we call like 5 here, this doesn't match, right? So it will go to the next pattern. And this one is a recursive call, right? So eventually it will, yeah, it will arrive here and finish the function. Same logic as the other implementations. And but this one is like if it matches 0, it will go here. Otherwise, you see, it will match this one. Let's try it. Yeah, it works, right? Now how can we do GCD? So that, yeah, remember that is only needed inside the GHCI here. So okay, so let G of M and okay, now we'll try to match, right? So here, if n is 0, it will be M, and if it is otherwise, it will be G of n and mod M and that, right? Same logic, different syntax. So you'll try to match this one. If this matching fails, it will go to the next pattern, right? So if the n is not 0, then it will go to the this pattern. Okay, g of 5 and what, let's try another one, 24 and 36. What is that? 12, right? Yeah. So also very elegant, right? So this is our third way to implement factorial and GCD. We put the patterns in order, right? Yeah, so that's it. Thank you for watching. See you next time.